Okay, because we are calculating rate of change and projecting forward with climate, I have my Google Calculator all set up. So I've got our summary of points up here at the top, just as a reminder of how we're working all of these through. There's 4 different graphs to think through, and each one I kind of scaled back on my help a little bit. So by the time you get to graph 4, that's more what you're going to be seeing on the final, where you are doing all of these steps on your own. So first thing we're doing here is picking 2 points on the recent graph. Again, trying to stay towards the more recent time of the graph and stick with a 5 to 20 year span. And like we said in class when we were practicing, pick points that you can easily read. If it's a graph going by every 5 years, don't try to find, 2002 to 2011. Make it easy for yourself. So I already gave you the 2 points that we're going to use today, and actually filled them in already on our table down here at the bottom. So we have our 2 points ready to go. Next is I need to subtract my y values and my x values. So a reminder here that this is our y-axis, which is our global average temperature, and here is our x-axis. So my x-axis is looking at our change in years, which of course, as I plug that into the calculator, if you need to, we're looking at 2020 minus 2015, getting a total difference of 5 years. And our y-axis, our temperature, 15 minus 14.75. And again, those numbers are just coming right here from the data points that I already gave you. That one has a change of 0.25 temperature. So those numbers I'm just placing into my formula here. I've got 0.25 change in temperature every 5 years. Well, to finish my rate of change, I need to divide those two. And the biggest thing I've seen people mixing up lately is remembering to have the x value, the time, that needs to be on the bottom of our calculation. So here we're making sure that we do 0.25 divided by 5. So it's my change in temperature over 5 years. That works out to be a change of 0.05 degrees every single year. And that is my rate of change that I'm going to use and apply to my 20-year projection and my 100-year projection. So I'm using this rate of change to fast forward, well, how much would it change over both a 20-year time and a 100-year time? So starting with my rate of change, 0.05, forwarding out 20 years, what would that amount be that we would see temperature go up in 20 years' time? It would change 1 degree. And same thing here for 100 years. What would that forecast be if I'm looking at a change of 100? 0.05 times 100, a change of 5 degrees. So now I have my projection. My last part is thinking about, well, what would the graph actually say? What would the real temperature be in those time frames? This is just an increase amount, right? If I go back up here to my graph and try to put 1 degree on my graph, I'm pages below this, so I know I'm not totally done yet. So here's what I'm thinking about is this is telling me temperatures are going up by 1 degree 20 years time. So in 20 years from now, right, this is our now, 20 years from now, it's going to go up 1 degree. Well, that means in the year 2040, I'm thinking about my current temperature, 15, plus the amount it's going to increase, 1, giving me a total of 16 degrees for our global mean temperature in the year 2040. And same thing here. I'm thinking about my current temperature, or average temperature rather, being 15. It's going up 5 degrees in the next 100 years, so I'm going to add those together to get my total of 20 degrees average for the Earth's temperature in the year 2120. So I've always got my directions up here at the top. Those are all the steps we worked through. Whoops. We picked 2 points, or we used the 2 given points. We subtracted, we divided, and then we projected forward, multiplying by both 20 years and 100 years, because that's what we were looking at. And then we added those 2 numbers together to get our projected amount. So looking at graph number 2, here it's set up the same, but you have a little less down here as I kind of help you figure this out a little bit more on your own. And you can always scroll back up to the directions or the full example. So here we've got point B as 2020 and carbon emissions of, or carbon parts per million at 414. Point A is looking at the year 2000, carbon emissions of 368. So again, I've got my x-axis down here, that's my years. My y-axis over here, that's my carbon. And I need to do subtraction. So I've got 2020 minus the year 2000, so that's a 20-year span. And here I'm looking at 414 parts per million minus 368. 414 minus 368. That is not what I wanted. 414 minus 368. There we go. So we're seeing a 46 parts per million increase over 20 years time. So this is where I divide to get my ratio per year. 46 divided by 20. So I'm looking at a change of 2.3 parts per million of carbon each year. So again, I have to fast forward that out to figure out my change for 20 years and 100 years. And then to get my 2040 and my 2100 value, I add to the current, right? So I'm going to add that, both of those, to my current value. So here you're going to notice I gave you just the years, but you need to do your notability tool and pull over and get what your loss of ice is going to be. And here I didn't give you any data. You've got to find your points, reminding that you're picking 2 that are recent in that 5 to 20 year span and easy to read on the graph. So like we said, don't try to do 2012 or 2001. Okay, just stick to what you know. This bottom part here is looking at climate impacts in Minnesota. So you're starting out with a short video, and then each section has a graphic to look at to answer the questions. As always, let me know how I can help.